find the general formulas for delta y and delta x, or delta y and dy, when y is equal to, so this is page, what, 56, number 4, y is 2 over x, and I want to find dy, and I want to find delta y. Alright, so dy is equal to f prime of x times dx. So I'm going to rewrite y as 2 times x to the negative 1 power. So dy dx is going to be equal to negative 2 times x to the negative 2nd power. So dy is going to be equal to negative 2 over x squared dx. So there's your first part. There's your, that would be your quick power rule to get there. So that's for dy. Now delta y. Delta y is equal to f of x plus delta x minus f of x. Which means I have to take this guy, 2 over x plus delta x, minus 2 over x. That's going to be my delta x, or delta y. I'm not using this at all for this. I use the original function for that. So now, I'm going to do, since I'm just adding two fractions, I'll do the a plus b, or a over b minus c over d, where I take a times d minus b times c over b times d. Nope. So it's 2x, then it'll be minus 2x minus 2 delta x all over x times x plus delta x. So it would be 2 times x, which is 2x, minus 2 times x, which is minus 2x, minus 2 times delta x, which is minus 2 delta x. And we have that. Now, can I get rid of anything in this case? Yeah, I get 2x minus 2x. That stuff's gone. So I'll be left with negative 2 delta x all over x times x plus delta x. And there's my delta y. And so those are your two equations for that. Then if we knew what delta x was and dx and x, we could plug them in there and see what happens. There it is. Because the original function, this is f of x. So if I changed x to x plus delta x, this just becomes x plus delta x. So I had the 2 from here, and I have to change that guy into x plus delta x, which I did right here. So instead of having 2 over x, I had 2 over x plus delta x, because my x variable changed to x plus delta x. Correct. And you make those changes. Now, like I said, this is a little bit uglier than what we had over here. This would be nice. But here's the deal. This is an approximate change in y. So if we're looking at an x value, say we're looking at 2, if we're looking at x equals 2, what's f of 2 in this case? 2 over 2, which is 1. Now, if we're looking at x equals 2.01, my change in x is equal to 0.01, correct? Because I moved x just a little bit over. Now, dy is going to give me an approximate delta y is actually going to give me an approximate change in that 1. How is that 1 changing? We've been looking at how is 2 changing. 2 is changing by that 0.01. Now, what delta y gives us is, alright, that 1 isn't going to be 1. It's going to be something different. Now, this is going to tell me, when I figure out what delta y is, it's going to give me an approximate value of what that change is. Or dy, the differential here. Delta y gives me the exact change. That's going to give me the exact value of the change from one to the other one. Now, the best way to look at this, now let me change one thing really quick here for you so you can see the differences that are going on here. Alright, come on. Equation's 2 over x. If I go 2 divided by 2.01, this is going to give me the exact answer, isn't it? So, was equal to the 0.995025. Now, if I go for dy, and if we looked at our paper, dy is going to be equal to divided by, what did I change in x? X is going to 2.01, right? 2.0 0.01. Well, it went from x to x.01. And so this is the because I like that one better. Actually, one. I got my answer to be 1. That was the exact answer. That was the approximate answer that we got. Now, if I go into delta x is a lot different because this is going to be -2 times, what was the change? 0.01. dy got us to 0.9950, what, 5? delta y got us to 0.995025, which is exact. This guy's approximate. So when you're working through these problems, the difference between delta x and dx, or delta y and dy, your delta